So we're here at Crab Orchard Spillway, the stream channel below there. We wanted to talk a little bit about streams and their management and recreation associated with stream ecosystems here in the U.S. and even abroad. On summer camp, when we go to the Ozarks, we actually get to visit the Current River in Missouri. Probably some of you have floated that river. It's a popular recreational river, and it's part of a national scenic rivers area in that part of southeastern Missouri. And the Current River is a neat place because it's high quality recreational area, but also a high quality fisheries area. It's a cold water system, so that you can catch trout in the headwaters, and then a good smallmouth bass fishery as you move downstream. So it's a popular fishing destination. Hydrologically speaking, it's pretty unique here in the Midwest because it's a limestone fed stream, which with a lot of the limestone within that valley that it flows through, limestone, you get a lot of groundwater inputs moving through it because the limestone dissolves over time, and you get these big solution channels underground in that limestone bedrock. Like you learned probably in 3rd grade, you learned about groundwater definition was an underground river. Well, actually, that's a very unique part of a groundwater aquifer, or a unique example of a groundwater aquifer. Most times, a groundwater aquifer is just flowing through fractures in bedrock like shale or sandstone. But in limestone case, we can get big solution channels, and that's the reason we get the Current River is cold, because that groundwater is coming out into the channel at 57 degrees Fahrenheit, and that's pretty stable year-round. For instance, over here on the Illinois side, we don't have a lot of pure or mostly groundwater-fed streams, so most of our streams will dry up in the summertime as the water tables drop, right? Then they're no longer fed by groundwater, and that's why if you go hiking around in the woods in southern Illinois, a lot of our streams by June, July, August, they're not gonna have flow in them because we don't have the groundwater table up above the surface of the stream bed. Therefore, they're not gaining streams, but they're actually, once that groundwater table drops below the bed, they'd be an example of a losing stream. So again, take a chance if you get over to Missouri in the Eminence area. There's also Jack's Fork that the current flows into. Great recreational area for canoeing and kayaking. Great place to explore. Again, good fishery because it's a cold water fishery due to all that groundwater coming in. And we look at examples of some of the springs in the area. They have Big Spring, they have Blue Spring, which is a brilliant blue color, almost like a Kool-Aid type blue color, due to differences in the dissolved minerals. For instance, the calcium. So your main minerals in limestone are your calcium and magnesium. Depending upon the type of calcium and that ratio of calcium to magnesium, you'll get different colors of the water. Like the Current River itself, it's going to look pretty green, and that's usually a telltale sign of a limestone stream, versus that Blue Spring actually has a pretty unique blue color. So try to check that out as well. And that area contains, I think, 7 of the 10 largest springs in the state of Missouri. So it's a pretty neat place to visit. Take an opportunity to do that.
All right, so now we're going to talk a little bit about reservoirs. Dr. Williard just covered rivers, so we're going to talk about the uses of reservoirs and what do you think they are? There's multiple uses. One, this is Crab Orchard Lake. We just came up from the spillway. You can see the guy obviously out there fishing, so recreation is one use of a reservoir. Flood control is another big one. So a lot of these farmers in Illinois, you know, if they didn't have dams and dam up some of these rivers and reservoirs, they wouldn't have the ability to irrigate their crop or have flood control. Another one is transport. That's a big one. Think of LBL, land between the lakes down there at Kentucky and Barkley Lakes. You've got those big lock and dam systems that created those reservoirs. Those reservoirs are not only for flood control, but it helps with river navigation. So when you think about a barge moving goods and services up and down the river, typically we got coal, gravel, a lot of grain is moved out of the state of Illinois through barges. One barge with 15 tows on it, so that's 5 deep and 3 wide. That's typically what fits through all our lock and dam systems. That's equivalent to 2.5 trains with 100 rail cars. So that's like 250 rail cars fit in one barge. So you think of it from a fuel perspective, that's a big deal. The same for semis going up and down the road. That's equivalent to 870 semi-trailers going up and down the road just in one barge with a 15-tow capacity. So transportation's a big deal. The river navigation, the whole system moving up and down, we can get all the way to the Gulf Coast. So we have lock and dam systems all the way up. Our lowest ones are down here around just south of Cairo. It's our last lock and dam on the Mississippi River, and then it's a free-flowing river down to the Gulf.
Talk about, John, while you're talking about Cairo, talk about the confluence of the Ohio, Mississippi, the importance of that.
Yeah, what's the name of the park down there? It's like Inspiration Park or something. Yeah. That's not what it is, but there's a park right down there at the confluence of Cairo, and that's a big river town. It had a lot of historical significance, and you think about where it's sitting, you think it still would, because you have the Mississippi River coming in and you've got the Ohio River coming in right there. That's like one of the 7 wonders of the world almost. That's like 2 major, very huge, large rivers that come together. That doesn't happen in very many places, and we have that occur right here at Southern Illinois. So there are a lot of transport facilities coming out of there down in Cairo, and just north there they have Bungie Ag. They've got a bunch of different ag producers down there that haul off a lot of grain. So a lot of our grain is hauled there on semis and then gets on barges and transported south from there. Another thing is hydroelectricity. So we can use these dams and reservoirs to generate hydroelectric power. The nearest one to us is probably Land Between the Lakes again. Both Kentucky and Barkley Dam have turbines, and they generate hydroelectric power at both of those reservoirs. So it's a free energy source, you know, you might as well use it. So that water's always moving those turbines, and those turbines spin and generate that electricity. Some other things, we talked about flood control, recreation, the hydroelectric power. What else, Carl, for reservoirs in terms of uses?
Well, you mentioned fishing, but a lot of wildlife usage.
Yeah. This is a national refuge, so we do have, you know, wintering. We actually have pelicans on the lake right now. I don't see any from here, but the pelicans have moved through. There's been a bunch of them, probably a few hundred pelicans, white pelicans, that are resting here right now. We've got Canada geese that come through here all the time, all kinds of waterfowl, ducks, a lot of different species of fish that live in this reservoir.
Public water supply. Yeah,
public water supply, that's another big one. Most of you probably get your drinking water from either Cedar Lake, there's an intake there and water treatment facility, or at Wren Lake. A lot of our water comes from there. So I'm north of Carterville. My water comes from Wren Lake and ends up in Cambria water supply and then pumps over to my way. But
why do we have so many reservoirs in southern Illinois compared to other regions?
There's, I mean, multiple reasons. A lot of it is flood control and sediment. Sediment's a big one, retention. So these basins are designed to capture a lot of these sediments when we have all this erosion. Where's all that stuff going to go, you know? So it's kind of like a big detention basin where all this sediment comes in. Think of the Kincaid Lake issue right now, how quick that's filling in. If you go up to Johnson Creek, the boat ramp, I used to go up there when I was y'all's age, and we'd go up fishing up there, and the boat ramp was deep. It was probably 10 feet deep right off the boat ramp, and now it's all silted in. They have to dredge at that boat ramp because all the land use and up slope, some of that agriculture on those hilltops is contributing a lot of sediment. So it does store a lot of that sediment over time.
And you mentioned earlier the public water supplies in
Yeah.
southern Illinois. One of the other big reasons is because we don't have good groundwater resources for drinking water, so reservoirs have really become the public drinking water source of choice in our region.
Yeah, when you're talking drinking water from groundwater sources here, a lot of these wells are drilled 200, 300 feet deep, and to put in a well that deep costs about $10,000 or $12,000. So a lot of these folks are still using on, you know, like Carl said, on these public water supplies. So just a lot easier.
Talk a little bit
Connected to
you
the
know,
system.
here in the humid part of the U.S., we don't do a lot of irrigation for agriculture, but talk about the importance of reservoirs, for instance, in the Great Plains and western United States, where we have more arid regions.
Yeah, in those western states, if you've ever flown over them, you see a lot of center pivot irrigation out there. So you'll be up in the plain and you'll see all these round circles on the landscape. If they didn't have that ability to capture water either from the river systems or reservoirs or even pumping it from groundwater, they wouldn't have agriculture out there. So we've talked about that in soils class, you know, the humid regions, and then some of the regions where it's suitable for crops, but you got to have irrigation. And then here in this eutic moisture regime, we have the suitable amount of moisture to grow crops. So irrigation is a big deal. And here you don't see it as much, but if you go out west, there's water wars. You know, there's different folks fighting over this water. We've got people, ski resorts that need the water. Then you move down slope, you got agriculture, you got a bunch of different people
And
trying to
public
use
water
that.
supply,
And then
right?
the public water supply. Everybody's kind of fighting over this water. And we even have that in the Atchafalaya Basin to the southeast. So Georgia, Florida, and Alabama, some of those states down there have some pretty significant water wars. They say the Chattahoochee River, if you've ever been down there, it's a pretty good sized river, and it's been recycled 2 or 3 times by the time it got down to us at Auburn from the city of Atlanta. So all that water was utilized, filtered back through the system, and we were basically using recycled water 3 times by the time it got down there. So
Talk a little, switch gears to large river systems. Some of the different ways we've managed large, you talked about navigation, but some of the things like we put out, for instance, levees, and talk a little bit about the importance of levees, why we have so many, and some of the other large river management we've done.
yeah, if you get down into southern Illinois especially, there's a road called Levee Road, and it goes for miles, and it's just kind of like what we're standing on here. This is a big levee or dam, but it just keeps or holds back the water of the Mississippi and Ohio rivers, so those farmers can get in there and have a crop that doesn't get flooded. There's pump systems on both sides of the levee, so when the water does get in, it can be pumped out, back out of the levee, back towards the river. You saw that down at Cape Girardeau this year. If you were down there, the bridge was shut down for a long time. The water was super high. We had a Chester Bridge was closed. We had a lot of water get on. It was actually seep water coming underneath the levee systems, so it was deeper. It wasn't coming over them, but going under them, and we couldn't pump it out fast enough to get that dried off. So I don't know what the status is right now, but I'd say they're pretty wet down there, even though it's been a relatively dry year. These last couple rains, we've seen, you know, a couple inches over the last couple days. So there could be some water issues down there now, but I'd say it's better than last year for sure. But
Talk about the lock and dam system that we have on the Mississippi and Ohio, and the importance of that, and really how a lock and dam works and how that aids navigation.
right, so like the Ohio River, I think it drops in elevation, I don't know, what is it, like 600 feet from where it originates to here. So in order to have barge navigation, the draft on a barge is probably 10 or 15 feet down into the water. So you got to have a place that barge can float and safely navigate the river. So obviously they have the red and green buoys for navigation. You stay in between them for to be in the river channel, but then you also have these lock and dam systems, and basically what that is a stair step system, so you can drop pools and keep enough water in that pool so you can safely navigate it. Because if you didn't have those, there would be riffles showing in certain parts of the river. You'd have areas that the barges could not get through. So that lock and dam systems, like I said, you can move barges through them. A 3x5 barge will fit in some of these lock and dams. The new one they just built there at Olmsted, lock and dam's even bigger than that. You can, because if you have a barge that's bigger, you can push them down the river bigger than that, but you have to break them apart, and it takes a lot of time to navigate these different lock systems. So you might have to put 15 through at a time, go back through with your tug, get another 15, push them through. So the Olmsted lock and dam replaced what, 52 and 53. Some of the old locks that were starting to fail, a lot of those locks were getting older. So this is a new system. It was a, I don't know how many $22 billion project the Army Corps of Engineers was in charge of. So they had a lot of folks working down there for, it was about 22, 30 years, something like that. It was in the 30-year range. But they built that lock and dam system to replace 2 lock and dams. And there's just, like I said, there's a series of them. If you live anywhere along the Illinois or Mississippi River, you've heard of the pool numbers, pool 18, pool 19. And that's just the lock and dams coming down from like Hannibal, Beardstown, all those different cities. And they all have lock and dams, and mainly for the river navigation and flood control, because you can hold water back or you can send water down through regulating the gates on the lock and dam systems.
One thing I see when I cross the Mississippi, if I look up and even downstream, is these rock piles, veins that come out into the channel. What's the purpose of those?
Yeah, those weirs, some people call them Newberry weirs on a smaller scale, but those rock walls divert the water and keep that water moving quicker, keep that hungry water Dr. Willard was talking about, and it helps keep that main channel clean. So water will slow down. You'll actually have slack water behind those rock bars, and that's where some of the sediment will tend to accumulate because the water's slowed down, but it keeps it directed towards the channel, moving faster in the channel, and you've got basically you're keeping that navigational area open for traffic.
Does the Mississippi River itself look a lot different than it did, for instance, 200 years ago because of some of these things?
Right, yeah, and it kind of contains it. It directs the flow of the water and keeps it, kind of tames the river in a sense. You know, Dr. Willard was talking about rivers down below the dam and the natural meandering pattern, and that's what these rivers would do if we didn't put these big, large riprap structures or these gabion baskets or concrete walls or all these levees to help tame and control that river.
So it's a lot narrower river than it used to be, a lot narrower and deeper.
Right, narrower and straighter and deeper in the middle of the channel. So the main channel on the Mississippi and Ohio River run from about 40 to 60 feet deep out in the main channel. There's obviously shallower spots. You get it down around Thebes where we usually take your class, and there's those rock spires that stick up down there. It's called Thebes Gap, and that was one of the lowest fords on the Mississippi where you could actually cross the Mississippi back in the day and get safely across the river. So they've dynamited a lot of those big rock spires out so they could aid navigation.
Yeah, but during one of the last major droughts, right?
Yeah, and then that area, if you ever been down there, the Thebes Gap, those rock spires are perfect habitat for our sturgeon. And a lot of our fish, spoonbill and other species, will get in behind those rocks and use that habitat to spawn. So you see a lot of commercial fishing down in that area. Always see boats at the boat ramp, 24-foot boats, 8 foot wide, that are out running nets in that area.